Hey, happy April, everybody. I hope you've already watched the Professor Dave video, read my notes on combined gas law, and now here's a video of me solving combined gas law problems, all right? This problem reads, a 10-liter cylinder of oxygen at 25 degrees Celsius and 25 atmospheres is heated to 50 degrees Celsius. Calculate the new pressure in the tank. Well, I can tell that temperature is changing from 25 to 50 degrees Celsius. One variable affects the other, so we're going to use the combined gas law. I'm going to say P1 V1 over N1 T1 equals P2 V2 over N2 T2. Now, I don't need all these variables, all right, in here to solve this problem. If something is constant, there's no need to keep it on both sides of the equation if it's not changing. A 10-liter cylinder. Volume is not changing. This is a rigid cylinder, all right? The problem says nothing about the number of particles, so we're going to assume that the number of particles is constant as well. So simply P1 T1 equals P2 T2, all right? My initial pressure is 25 atmospheres at a temperature of 25 degrees Celsius. I cannot use Celsius in these kind of gas law problems. I must change to Kelvin by adding 273. So 25 degrees Celsius is 298 Kelvin. All right. What will be the new pressure at this higher temperature? Well, 50 plus 273 is 323 Kelvin. All right. The temperature goes up, particles are moving faster, there's going to be more collisions, the pressure should go up. I'm going to cross multiply and divide. 25 times 323 divided by 298. P2 is 27.1 atmospheres. All right. Another example. A 2-liter balloon of helium at STP. STP is standard temperature and pressure. It stands for 1 atmosphere pressure and 0 degrees Celsius. All right. This balloon is heated and pressurized, so conditions are changing. Calculate the new volume of the balloon. All right. Combined gas law again. P1 V1 over N1 T1 equals P2 V2 over N2 T2, all right? I think the only thing that's staying constant here is the number of particles, all right? It's not changing, we're not adding to it, we're not taking it away, all right? So my initial pressure, STP, is 1 atmosphere. My second pressure is in a different unit. I may use any unit I want to for pressure as long as I'm consistent on both sides. 1 atmosphere is equivalent to 760 torr. So I think I'm going to use that. P1 V1 over T1 equals P2 V2 over T2. My initial pressure is 760 torr. When my volume is 2.0 liters. At a temperature of 0 degrees Celsius, I can't put 0 in the equation. Kelvin is the only scale proportional to kinetic energy. So 0 plus 273 is 273 Kelvin, all right? My new pressure is 900 torr, all right? I don't need to put these units in here for the math. I just need to know they're consistent. I'm solving for a new volume when the temperature is 100 degrees Celsius or 373 Kelvin. There's more numbers here. There's one variable that makes this all correct. I still cross multiply and divide. I'm going to multiply these 3 numbers in this diagonal and divide by both of these, all right? Any way I want to. Check your math, plug it into your calculator, and you should get V2 is 2.3 liters, all right? My last example problem today. My propane tank, when filled with 6 moles of gas, reads 35.2 psi at 21 degrees Celsius. How many moles of gas remain after I use it once and the pressure is down to 33 psi and the temperature is 30 degrees Celsius? conditions are changing. P1 V1 over N1 T1 equals P2 V2 over N2 T2, all right? This time I cannot leave off N for the number of particles because it's changing. I'm using some of the gas. Volume I can leave out here because the volume of this tank is not going to change, all right? It's a rigid metal cylinder, all right? I'm going to stay in PSI. My initial pressure is 35.2 PSI. This is the pressure when there are 6 moles of gas in the tank. And the temperature is 294 Kelvin. I get that by adding 21 to 273. Okay? These are my initial conditions. I left volume out, all right? The pressure reduces to 33 PSI. I must have used some of the gas in that tank. We're solving for the number of moles. The temperature is now 30 degrees Celsius or 303 Kelvin. And what I'm solving for is what makes this mathematically equivalent. I'm still going to cross multiply and divide. Now I'm multiplying this diagonal, 33 times 294 times 6, and then dividing by 35.2 and dividing by 303 and 2. My calculator should say, and yours should say 5.5. What is the label on there? It's the same label as here. This is going to be moles. All right. The last problem, my pressure was in torr. This time I'm using PSI, and that's okay as long as I'm consistent. All right. Hey, check in during office hours. I really, really want to see you. Peace out. Keep your stick on the ice.